So good evening class. Today's topic is sequence and series. Oh shit. Uh, minute here. One second. One second. One second. One second. Yeah. So let's start with the first question. So our first question is, if 1 log 3 to the power 1 minus x plus 2 to the base 9 and log 4 into 3 to the power x minus 1 to the base 3 are in AP, then x equals to. So if we are having these three terms in AP, then second term log, we know that if A, B, C are in AP, then 2 times of B is equals to A plus C. So using this concept, 2 times of log 3 1 to the power 1 minus x to the base 2 to the base 9 equals to 1 plus log 4 into 3 to the power x minus 1 to the base 3. Now here this 9 we can write it as 3 to the power 2, and we know that from the property of log this power will come in division, so this will get cancelled out, and this 1 we can write as log 3 to the base 3. So we would be getting 3 to the power 1 minus x plus 2 equals to 3 into 4 into 3 to the power x minus 1. Now here we are getting 3 upon 3 to the power x plus 2 equals to 12 into 3 to the power x minus 3. So let's say this 3 to the power x is equals to some value t. So we would be getting 3 upon t equals to 12t minus 5, or 12t square minus 5t equals to 3. From this we will get a quadratic equation, 12t square minus 5t minus 3 equals to 0. So on factorizing, we will get 3t plus 1 into 4t minus 3 equals to 0. So value of t will be either minus 1 by 3 or t will be 3 by 4. Now 3 to the power x, this value cannot be negative, so t cannot be equals to minus 1 by 3. This implies the value of t is 3 by 4. So 3 to the power x is equals to 3 by 4. This implies x is equals to log 3 by 4 to the base 3, that is x is equals to 1 minus log 4 to the base 3. So the correct answer we are getting here is B. Yeah, good. So let's move to the next question. Our next question is the sum of the infinite number of terms in GP is 20 and the sum of their squares is 100. We need to find the common ratio of GP. So let's say we are having an infinite GP A plus AR square plus so on up to infinity. And the sum of the infinite number of terms, that is A upon 1 minus R, is equals to 20. From this we will be getting A equals to 20 into 1 minus R. And the sum of their squares, let's say it's S1 is equals to A square plus A square R square plus A square R to the power 4 plus so on up to infinity. So this sum will be equals to A square upon 1 minus R square, which we can write it as A upon 1 minus R into A upon 1 plus R. Since the value of A upon 1 minus R is 20, so 20 into A is 20 into 1 minus R upon 1 plus R, and this value we are given it as 100. So from here 4 minus 4R is equals to 1 plus R, that is 3 equals to 5R or R equals to 3 by 5. So the common ratio of this GP is 3 by 5. Is it clear? So moving to the next question. Okay, I'm giving you 20-second time for this one. We are given the fifth term of the GP is 2, and we need to find the product of its 9 terms. So T5 is 2, that is A into R to the power 4 is equals to 2. So the product of first 9 terms will be A into AR square into so on up to AR to the power 8. So A to the power 9 into R to the power 1 plus 2 plus 3 plus so on up to 8. That will be A to the power 9 into R to the power 4 into this first term plus last term 9. So that will be AR to the power 4 whole to the power 9. And AR to the power 4 is 2. So this will be 2 to the power 9, which is equals to 512. So the correct option is B. Yep. Moving to the next question. If the system of linear equations x plus 2ay plus az equals to 0, x plus 3by plus bz equals to 0, and x plus 4cy plus cz equals to 0 have non-zero solutions, then ABC equals to. Again, 30-second time. So we know that if this is a system of linear equations, then the determinant value of the coefficients should be equals to 0. Then only we will get the non-zero solutions. So 1, 2a, 1, 3b, and 1, 4c should be equals to 0. So 1, using these two operations, in R2 I am putting R2 minus R1, and in R3 I am putting the operation R3 minus R1. So 1, 0, 0, 2a, on this will be 3b minus 2a, b minus a, 4c minus 3b, and 4c minus 2a and c minus a. So on solving, we will be getting 3b minus 2a into c minus a minus b minus a into 4c minus 2a equals to 0. So from this, you would be getting 2ac minus bc minus ba equals to 0. On simplifying this, so you would be getting b is equals to 2ac upon a plus c. This is the condition for the terms to be in HP. This implies that A, B, C are in HP. Yeah, correct. Moving to the next one. Right, fast, fast, fast. Okay, so we are given that fx is a polynomial function of second degree. So the fx will be an equation ax square plus bx plus c. We are also given that f of 1 is equals to f of minus 1, that is a plus b plus c is equals to a minus b plus c. From this, we will be getting b equals to 0. So we are having this fx equals to ax square plus c. It is also given that, let's take this capital A, capital B, and capital C, because small a, b, c are already in the question. So fx is ax square plus c1. Now we are given that a, b, c are in AP, then first we need to find f dash x, so that will be 2ax. Now f dash a will be 2aa, f dash b will be 2ab, and f dash c will be 2ac. Since ABC are in AP, and we know that if we will multiply each term with the same value, then there again also the terms will be in AP. If we will be multiplying each term by 2a, then the new sequence will be again AP. So 2aa, 2ab, and 2ac will be in AP. So from this, we can say that f dash a, f dash b, f dash c, they are also in AP. Now moving to the next question. We are given x1, x2, x3 and y1, y2, y3 both in GP with the same common ratio. Then the points x1, y1, x2, y2 and x3, y3 are. Okay, 30-second time. Yep, it is D. So we are having x1, x2 and x3 in GP. Let's say that common ratio is R. So x2 would be x1 into R and x3 would be x1 into R square. So our points are x1, x1R and x1R square. And y coordinates will be y1, y1R and y1R square. So we are having these 3 points. Let's say A, B and C. So from this we can see that the slope of AB would be y2 minus y1 upon x2 minus x1. So that will be y1r minus y1 upon x1r minus x1. From this, taking y1 common, r minus 1 upon x1 common, r minus 1, we are getting y1 upon x1. Similarly, if you find the slope of BC, let's say, then that will be y3 minus y2 upon x3 minus x2. So that would be y1r square minus y1r upon x1r square minus x1r. From this, y1 common upon x1. So we are getting the slopes equal. So this implies ABC lie on a straight line because these 3 points are collinear with point B lying in being common. Okay. So answer is D. Moving to the next question. Giving you 30-second time. After this class, I will call you. Yeah, wait. So we are given that theta R1 and R2 respectively with the maximum range up and down on an inclined plane and R with the maximum range on an horizontal plane. Then R1, R and R2 are. So for an inclined plane of inclination theta, the maximum range is given by up the incline if you are taking, then it is u square upon g 1 plus sine theta. This is the maximum range up the incline, and R2 is u square upon g1 minus sine theta. This is the maximum range down on an incline. And we already know for the horizontal range, it is u square upon 2g. So from these two, we can figure out that this 1 plus sine theta and if 1 minus sine theta, from this sine theta and sine theta get cancelled out, then we will get this form. But how we are getting it? If we are finding the value of 1 upon r1 plus 1 upon r2. So, oh sorry, u square y. So 1 upon r1 plus 1 upon r2, we are having as g1 plus sine theta upon u square plus g1 minus sine theta upon. From this, you would be getting 2g upon u square, which is 2 upon r. So these three terms are in HP. So the correct answer is C. Got it, Arushi? These two formulas are important, and this you already know. Moving to the next question. Now, this is a very simple question. You have already done it. So I'm giving you just 30-second time. So let TR be the Rth term of the AP whose first term is A and common difference is T. If for some positive integers m and n, Tm is 1 by n and Tn is 1 upon n, then we need to find the value of A minus T. So Tm will be A plus m minus 1 into D equals to 1 by n, and A plus n minus 1 into D equals to 1 upon m. Subtracting these two equations, we would be getting m minus n into D. Let's name this equation 1, equation 2. We are doing equation 1 minus equation 2. So from this, D would be equals to 1 upon m into n. Putting this value of D in here, we will be getting A plus m minus 1 upon mn equals to 1 upon n. So A plus m upon mn minus this equals to 1 upon n. So A plus 1 by n minus this is equals to this. So A is also equals to 1 upon mn. So from this, we can see that both the values are equal. So A minus D is obviously 0. Moving to the next question. If the coefficients of rth, r plus 1th and r plus 2th terms in the binomial expansion of 1 plus y to the power m are in AP, then m and r satisfy the equation. We have already covered this question in our binomial theorem. So we are not going to do it again. Just remember, its answer is B. Okay. Moving to the next question. If x is equals to summation n equals to 0 to infinity a to the power n, y equals to summation n equals to 0 to infinity b to the power n, and z equals to summation n equals to 0 to infinity c to the power n, where a, b, c are in AP and mod a, mod b and mod c are less than 1, then x, y, z are in. So x will be, this is an infinite GP, so the formula of infinite GP is first term upon 1 minus common ratio. So the first term is 1 because x we can write it as 1 plus a square plus so on. Y we can write it as 1 plus b square plus so on, and z we can write it as 1 plus c square plus so on. So x will be equals to 1 upon 1 minus a, y will be equals to 1 upon 1 minus b, and z will be equals to 1 upon 1 minus c. From this, we can write it as 1 minus a equals to 1 upon x, or a equals to 1 minus 1 upon x, b equals to 1 minus 1 upon y, and similarly c equals to 1 minus 1 by z. Now it is given that x, y, z are in AP. So okay, if we are given that A, B, C are in AP, we need to find x, y, z. So 2 times of B is equals to A plus C. So 2 minus 2 upon y equals to 1 minus 1 by x plus 1 minus 1 by y. So these terms will get cancelled out, and 2 upon y will be equals to 1 by x plus 1 by z. So we can see here that x, y, z are in HP. So the correct answer is A. Moving to the next question. If A1, A2, A3, so on up to AN are in GP, then the determinant value is equal to. Do you remember this question? We have already covered it in determinants. Its answer is, so you always see for this n plus 6, and its average n plus 3 here, n plus 1, n plus 7, and its average n plus 4 is here, n plus 2, n plus 8, and its average n plus 5 is here. So the determinant value will be 0, because when you will write it, then the power will come in front due to the property of log, and from that if you will apply the simple operation that is in R2, if you will write it like R2 minus R1 plus R3 by 2, you will be getting the whole second row as 0. Let's do it. So log an will be a1 into r to the power n minus 1 log a1 into r to the power n log a1 into r to the power n plus 1. This will be log a1 into r to the power n plus 2 log a1 into r to the power n plus 3 and log a1 into r to the power n plus 5, 4. This will be log a1 into r to the power n plus 5 log a1 into r to the power n plus 6 and log a1 into r to the power n plus 7. So using this operation, if we are doing r1 plus r3, then due to the property of log, these two terms will be multiplied. So that will be a1 square into r to the power n minus 1 plus n plus, this will be 2n plus 4, that will be a1 into r to the power n plus 2 whole square with log in here. So 2 will come in front, and we are also having 1 by 2. So this 2 will get cancelled out by this 2, and we will getting the term of a21, that is second row and first column. Got it? And similarly we will get this term, and similarly you will get this term. So the whole answer will come out to be 0. So moving to the next question. We are given, let a1, a2, a3, so on be the terms of an AP. Then if a1 plus a2 plus so on up to the sum of the p8 term upon sum of the first q8 terms is p square by q square, then we need to find a6 upon a21. So sum of the first p terms will be p by 2, 2a1 plus p minus 1 into d. And here it will be q by 2, 2a1 plus q minus 1 into d. And it is equals to p square by q square. 2 will get cancelled out, p will get cancelled out, q will get cancelled out. So on dividing the row first and the second terms by 2, we'll be getting a1 plus p minus 1 by 2d upon a1 plus q minus 1 by 2d equals to p upon q. Now here we need to find a6 upon a21, that is we need to find a plus 5d upon a plus 20d. So in place of p minus 1 by 2 we are having 5, that is in place of p we need to put value 11. Similarly, in place of q minus 1 by 2 we are having value 20, so in place of q we are having the value 41. So on substituting these two values, we will be getting a1 plus 5d upon, that is a6 upon a21. We are having a1 plus 5d upon a1 plus 21d. Yeah, sorry, 20d is equals to 11 upon 41. So the correct answer is D. Clear with this one? Moving to the next question. Okay, giving you 30-second time for this one. So we are given that A1, A2, so on up to AN are in HP, then the expression A1, A2 plus A2, A3, so on up to AN minus 1 AN is equals to. Since these are in HP, we know that if the terms are in HP, A1, A2, A3, so on AN are in HP, then this implies that 1 upon A1, 1 upon A2, 1 upon A3, so on up to 1 upon AN are in AP. So 1 upon a2 minus 1 upon a1 will be equals to 1 upon a3 minus 1 upon a2 will be equals to 1 upon a4 minus 1 upon a3, and so on. 1 upon an minus 1 upon an minus 1 will be equals to the common difference t. From here we can see that a1 minus a2 upon d will be equals to a1 a2. If we are equating this with the common difference, if we are doing the similar thing with the second term and the common difference, then we would be getting a2 minus a3 upon d equals to a2 a3, and so on. So thus we are having as a1 minus a2 upon d plus a2 minus a3 upon d plus so on up to the last term will be an minus 1 minus an upon d. This will be equals to the total sum. Now a2 will be cancelled out, a3 will be cancelled out, so on the terms will be cancelled out, and we will be left with a1 minus an upon d. Now we know that 1 upon an will be the nth term of this AP. So 1 upon an will be equals to 1 upon a1 plus n minus 1 into d. So from this, 1 upon an minus 1 upon a1 equals to n minus 1 into d. So a1 minus an upon a1 an is equals to n minus 1 into d. So a1 an will go this side and d will come this side. So this value is equals to n minus 1 into a1 an. So the correct option we are getting here is D. Is it clear? Okay, this is one method. What else you can do is, you can take the three terms as 1, 1 by 2 and 1 by 3. Now, they are having only the three terms. So A1, A2 will be 1 into 1 by 2 plus A2, A3 will be 1 by 2 into 1 by 3. And you can put the all the options and check for it. We are putting here n equals to 3. So when you will put n equals to 3 in here and check, then this value will be getting 1 by 2, you will be getting common. This will be 4 by 3, that is 2 by 3 you are having. So from the options, first option n is 3, 3 into 1 minus 1 upon 3. So this is not the correct option. For this one, 3 minus 1, it will be 2, and a1 minus an, again 1 minus 1 by 3. So we are having 4 by 3 in here. This is not the correct option. And a1 an, so that would be 3 into 1 into 1 by 3. So this is again not the correct option. From this one, this is 2 into a1 an. So this is 1 into 1 by 3, that is 2 by 3. So this is the correct option. Got it? How you can solve it? By putting some values in it. For most of the questions, you can do it like this. But make sure if you are getting two answers, then you have to check for the other values also. Like if the option B and C would be satisfying this condition, or says B or D is satisfying this condition, then we will take two different values, means one side is this, then another set, and then you have to check for it. Is it clear? Okay, moving to the next question. Our next question is, in a geometric progression consisting of the positive terms, each terms equal the sum of the next two terms, then the common ratio of this progression is. So we can take any general term, ar to the power n, then each term equals to the sum of the next two terms. So ar to the power n plus 1 plus ar to the power n plus 2. So from this we will be getting 1 equals to r plus r square, or r square plus r minus 1 equals to 0. So the value of r would be minus 1 plus minus under the root b square minus 4ac upon 2a. So that will be root 5 by 2. But it is given that it consists of the positive terms, so it cannot be minus 1 minus root 5. So r can be minus 1 plus root 5 by 2. So our option is root 5 minus 1 by 2. B. Clear? Going to the next question. The first two terms of the geometric progression add up to 12. The sum of the third and the fourth term is 48. If the terms of the geometric progression are alternatively positive and negative, then the first term is. So we are given that the first two terms of the GP add up to 12. Okay, I'm giving you 30-second time. Be fast. So we are given the first two terms of the GP add up to 12. So that is A plus AR is equals to 12. The sum of the third and the fourth term, that is AR square and AR cube, is 48. This is question 2. So simply R square we can take out an A plus AR equals to 48. So A plus AR is 12. So R square into 12 equals to 48. So from this R square is equals to 4. So R can be plus minus 2. But it is given that they are alternatively positive and negative. That means R is minus 2. Putting R equals to minus 2 in here, first equation we will be getting A minus 2A is equals to 12. So A we are getting minus 12. So the correct option is C. How many of you got C? That's cool. Moving to the next question. Yes, that's the end of the slide. So we are starting with multiple choice questions now. Okay. Now we are having the first question is it audible? Yeah. So A, B, C are in HP, then we need to check for these conditions. These are the multiple choice question. You will be getting more than one option correct. Okay. So since ABC are in HP, we are checking it for the first one. Since ABC are in HP, we can say that 1 upon A, 1 upon B, and 1 upon C are in AP. So multiplying each term by A plus B plus C, we are having A plus B plus C upon A plus B plus C upon B, and A plus B plus C upon C are in AP. Now, we are having minus 1 in here and minus B there and minus C there. So adding minus 2 to each term, we would be getting A plus B plus C upon A minus 2, and the next term would be A plus B plus C upon B minus 2, and A plus B plus C upon C minus 2. So on simplifying, we would be getting B plus C minus A upon A, B plus, A plus C minus B upon B, and A plus B minus C upon C in AP. Now their reciprocal would be in HP. So obviously the first option is correct. Let's check for the second option. Yeah, A is correct. Let's check for the B. So for option B, let's check RHS. So we are having 1 upon B minus A plus 1 upon B minus C. On solving, you will be getting B minus C plus B minus A upon B square minus A plus C into B plus AC. So in numerator, you are having 2B minus A plus C upon B square minus A plus C into B plus AC. Since ABC are in HP, so we would be having B equals to 2AC upon A plus C. So from here we can see that the value of A plus C, or we can say AC, is B into A plus C by 2. So putting this value of AC as B into A plus C by 2. So from 1 we are having this is 1 and this is 1 by 2. So we would be getting minus of this, and 2 would be getting here, and taking LCM 2 would be there, and taking out B common. So these two terms will get cancelled out and we will be getting 2 upon b. So yeah, option B is correct. Now let's check for option C. For option C, we need to check whether these three terms are in GP. So for GP, if we are having x, y, z in CP, then y square is equals to xg. So let's multiply these two terms. A minus b by 2 into c minus b by 2. We will be having AC minus c into b by 2 minus a into b by 2 plus b square by 4. So that is AC minus a plus c into b by 2 plus b square by 4. Now again we have seen that AC is b into a plus c by 2. So that is b into a plus c upon 2. So we'll be having b square by 4 minus. So we are having these two terms same. They will get cancelled out. So I have to get worried. So that is b square by 4. That is b by 2 whole square. Yeah, so these three terms are in GP. Now let's check for the option number D. For option number D, we were already having A, B, C were in HP. So we can say 1 upon A, 1 upon B, and 1 upon C in AP. So multiplying by A plus B plus C, we would be getting A plus B plus C upon A plus B plus C upon B, and A plus B plus C upon C in AP. Adding minus 1 with each term, we will get B plus C upon A plus C upon B, and A plus B upon C in AP. So they're reciprocal in HP. So our option D is also correct. So from here we can say that all the four options are correct. Is it clear? So moving to the next question. We are given an is equals to 1, 1, 1, 1, 1 n times. Then we need to check for all these terms whether they are prime or not. So for the first term, 912, we can see here that 9 plus 1 plus 2, it is 12, and 12 is divisible by, so this whole terms when we will add, then it will be 1 plus 1 plus 1, 912 times. So that value will come out to be 912, and 912 is divisible by 3 and other 12 4 also, because and will be 12 multiple of 4. So last two digits, if they are divisible by 4, then the whole term is divisible by 4. So this is not prime. Yeah, correct. Now let's check for the other terms. So the other terms, this is also divisible by 3. So this is also not a prime number, because on adding you are getting a sum which is divisible by 3. And this, you can easily see that this term again is divisible by 3. So all these are divisible by 3. Now 9 plus 1 is 10, so it is not divisible by 3. Now let's check whether this term will be prime or not. So A91 will be 1, 1, 1, so on up to 91 times. So let's multiply and divide by 9. So A91 will be 1 upon 9, and 999, 91 times. So A91 will be 1 upon 9 and A99991 times will be equals to 10 to the power 91 minus 1. Now here A91 is 1 upon 9. So 91 we are having 10 to the power 7 to the power 13 minus 1. Okay. Now what this our basic rule is, we have already cleared this, is that if we are having a GP, okay, so the summation of, if you can see here that the common ratio will be either 10, or we can say the common ratio here we are getting is 10 to the power 7. So if we are having a common ratio 10 and you are finding the sum of this GP from R equals to, let's say, 0 to n, then this value will be 10 to the power n minus 1 upon 9. So if I'll multiply it by 10 to the power 7 minus 1 here, and here also 10 to the power 7 minus 1. So multiplying and divide by 10 to the power 7 minus 1. This 9 I can write it as 10 minus 1. So we can say that these are two different GPs we are getting here. This first one is a GP whose common ratio is 10 to the power 7, and the second one is a GP whose common ratio is 10. The first one contains 13 terms and the second one contains 7 terms. So our first one will be 1 plus 10 to the power 7 plus 10 to the power 7 square, so on up to 10 to the power 7 to the power 12, multiplied by the second one is 1 plus 10 plus 10 square plus so on up to 10 to the power 6. So we can see here that it is not a prime number, it is a composite number, which is a multiplication of these two. So A91 is not a prime. Clear? Let's move to the next question. So we are given for the series S equals to 1 plus 1 upon 1 plus 3 and in bracket 1 plus 2 whole square. So we can write the general term as, yeah, sure. See, this question, what we were having is an was 1 n times. So if we will see 912 will be 1 times, and on adding 1 plus 1 plus 1 912 times, then it would be 912. And obviously if the sum of the digits is divisible by 3, then the number is divisible by 3. So this number is divisible by 3 as well as 912, so it is not a prime. Similarly, here also sum of the digits will be divisible by 9, divisible by 3. So this is also not a prime. Here also the sum of the digits is divisible by 3. So it is also not a prime. Now we have to check for A91. So A91 we have written as 1 times. So we have multiplied and divided by 9. So we have got A91 equals to 1 by 9 here, and multiplying each term by 9, we will be getting 991 times. So here we know that this term will be equals to 8 10 to the power 91 minus 1. See, 9 we can write as 10 to the power minus 1, 99 we can write as 10 to the power 2 minus 1, 999 we can write as 10 to the power 3 minus 1. So 91 times will be 10 to the power 91 minus 1. Now here we can see that 91 is 7 into 13. So we can write 10 to the power 7 whole to the power 13 minus 1. So if we look at it, then we are having this A91 as 10 to the power 7 whole to the power 13 minus 1. And this 1 upon 9 we are having. Now we can write it in the form of GP. If we are having this as the number of terms and this common ratio, then the sum of GPs is R to the power n minus 1 upon R minus 1. So here R is 10 to the power 7. So I have divided it by 10 to the power minus 10 to the power 7 and minus 1 and multiplied it by 10 to the power 7 minus 1. And this 1 upon 9, we wrote it as 10 minus 1. So here we can see that this A91 is the sum of two GPs. The first GP whose first term is 1 and common ratio is 10 to the power 7. The second GP whose first term is 1 and common ratio is 10. Here the number of terms are 13 and here the number of terms are 7. From the formula this, or from a general formula of GP, a to the power r equals to 0 to n, you will write it as a to the power n minus 1 upon a minus 1. So this we are having as a multiplication of two different GPs, and this is obviously a natural number and this is a natural number. So we can say that A91 is a product of two natural numbers. So it is a composite number and not a prime number. Are we clear now? So moving to the next question. Our next question is, we can write S equals to summation of, or we can write the general term. The general term will be equals to 1 plus 2 plus 3 plus so on up to, see, this is the first term, this is second term, this is third term, this is fourth term. So 1 plus 2 plus 3 plus so on up to n whole square, and in denominator what we are having is 1 plus 3 plus 5 plus so on up to 2n minus 1. So above we are having the sum as n plus 1 by 2 whole square, and below we are having one more ap, whose number of terms are n only. So that will be number of terms divided by 2, first term plus last term. So that will give us n square into n plus 1 whole square by 4 and n square. So tr, let's write that n. So tn I am having as n plus 1 whole square by 4. So let's find the ninth term. So T9 will be 9 plus 1, that is 10 square by 4. So T9 is 25. So yeah, this is our correct option. Let's find the seventh term. So T7 would be equals to 7 plus 1, 8 square by 4. So that is 64 by 4. So that is 16. So B is our correct option. Now we need to find the first sum of first terms. So we can see here that the sum of first 10 terms would be S10 will be summation Tn from n equals to 1 to 10. So that would be 1 by 4 summation n equals to 1 to 10 n square plus 2n plus 1. So that would be 1 by 4 and n plus 1 by into 2n plus 1 by 6 plus 2 into, we can directly write 10 in here. So that would be n plus 1 into 2n plus 1 by 6 plus 2 times of n plus 1 by 2 plus n. So we are having this as, the term would be 5 not 5. So the correct option we are getting here is option C. Okay. So that's it for today. Thank you, class.